Hello and welcome. In this tutorial, we're exploring high-level project architecture in Incisor. We'll be using a sample game to demonstrate how flow controllers and flow states handle your project's flow. This system not only keeps your code modular and timed, but also gives you a clear way to monitor the status and progress of your states during execution. Think of the flow controller as a manager of your project's current phase that tracks which state you're currently in. You can create one to define the major sections of your app, such as game introduction screen, main menu, gameplay, pause menu, and a game over screen. These states are globally accessible in your code and appear directly in the flow panel. This makes it easy to monitor timings and debug your project's sequencing in real time. Let's start by creating a new empty project. I'm going to call mine FlowStates example. To keep track of our states, I'll need to open the Flows panel. It's empty for now, but once we start defining our states, they'll all show up right here. Since these states are defined directly in code, I'm going to jump into the editor and open up our project main JavaScript file. First, I'll clear out the default template code that every new project starts with. To begin working with flow states, we need to define a flow controller using nc.defineFlowController. This takes a unique name as an argument. I'll just call mine default flow controller. If we check the flows panel, you'll see that the controller has been successfully registered. Now we can start defining the individual states for this controller. Each one should be a class that extends the base flow state class. While you could define them all in project main, it's better practice to keep them in separate files to keep things organized. That's why I'm creating a folder called flow states, and inside it, a dedicated JavaScript file for my introduction state. Our introduction class extends FlowState, which gives us access to all the built-in state management tools in Incisor. For example, we can use the addElement method to define elements. These elements act as timed callbacks, allowing us to easily sequence the events within our flow state. This method takes a timestamp as its first argument and the callback name as its second. I'll add an element to display the introduction screen at the 0-second mark, and then I'll add another element to hide it at the 2-second mark. Then, let's define those functions. I'll just leave them as empty stubs for now. Next, we need to register this new state with the flow state controller so it knows to include it in the logic. Now, if we look at the flows panel, you'll see the introduction flow state along with our two elements for showing and hiding the screen. However, the state isn't playing yet. To activate it, we need to call the setToCurrentState method to set this as our active flow. As you can see, the flow controller now automatically starts with the introduction state. It triggers our display element, waits for 2 seconds, and then seamlessly transitions to the hide element. Since we haven't defined any logic for our display and hide elements yet, you won't see any changes in the live view. Let's go ahead and quickly build a construct for the introduction screen so we can see it in action. If you're unfamiliar with Incisor constructs, there's a separate video tutorial that breaks that concept down in detail. You can find the link for that in the description below. I'm also creating a second construct for a gameplay screen. As a game, let's set up a simple coin flip example. I created a text box for displaying game status, and now I am importing a texture and a .obj file of a coin. You can find a link to those assets in the description. And let's add those constructs to the main scene via the code. Since they're both active at once, they'll show up together in the live view. To clean things up, let's hide them for now by setting their alpha to 0. Tweaking the color alpha of our screen instances allows us to easily show and hide them. Let's implement that in our introduction class. Inside the display introduction screen method, we can simply set the alpha to 1. We can also take advantage of Incisor's built-in color multiply swoop method to smoothly fade the color to desired value over a set duration, for example, 1 second. Now we need to define a flow state for our gameplay screen. I'll create a new file in the FlowStates directory and copy over the contents from our introduction state. Then I'll register this new state with the flow controller, following the same process we used for the introduction state earlier. In the FlowStates window, we can see that the gameplay state is registered. However, once the introduction ends, it doesn't automatically move on. That's because we haven't defined the transition yet. Inside the Hide Introduction Screen method, we simply need to tell the Flow controller to set gameplay as the active state. And there we go. The transition is now working correctly. I'm going to quickly fill in these text boxes so they actually show the game title and status. Since the introduction screen is static, I've updated its text directly in the construct. However, we'll update the gameplay status dynamically in the code, depending on which flow state the player is currently in. Once the game screen is displayed, I don't want to automatically trigger the hide method. Instead, I want to wait for the player to press the spacebar to proceed and start the game. To achieve this, we can use another built-in flow state function called add pause. This method keeps the state paused until the callback provided in the second argument returns true. For this callback, I'm writing a waitForUserInput function that returns the Boolean value of isWaitingForInput to determine if the flow should stay paused. In the displayGameScreen method, I'm setting this flag to true. This ensures the pause condition is met immediately and the state remains locked until we're ready to proceed. We'll flip this flag inside the onKeyDown callback, specifically checking for a spacebar input to move the game forward. We want this onKeyDown method to start listening after the introduction screen is displayed. To do that, let's hook into the built-in Incisor app events by adding a callback to nc.appevents.keydown. Then, it's important to unhook it as soon as the spacebar is pressed to prevent it from handling any additional inputs. Let's see it in action. As you can see, the flow is paused, but I'll hit the spacebar now and there we go. It moves to the next state. Let's also wipe the status text when the spacebar is pressed to keep the UI clean for the next state. Great, that's working well, but we're still missing the actual game. The coin flip logic can be defined as another element within our gameplay state. I'll quickly set up some basic randomization and apply rotation.swoop to the coin object to give us a nice and smooth flipping animation. Let's also update the status text during the flipping state to give the player better feedback. And finally, we can hook this method up as an element in our flow state to tie everything together. I'm going to give the flip a half-second delay to start after the user input pause is cleared. We also need to adjust the timing for our hide game screen element. Since the flipping animation takes 2 seconds, it finishes at the 2.5 second mark. I'll add another 1 second of hang time, which means I'll set the hide element to trigger at the 3.5 second mark. And there we have it. Our state machine is officially up and running. To make this feel like a complete experience, it'd be great to add one more state after the flip to display the result and then loop it back to the introduction. And to loop it back, simply go into the last element of our gameplay flow and tell the flow controller to set introduction as the current state. As you can see, once the game ends, it automatically transitions back to the introduction. This lets the player start a new round immediately without having to restart the game. If you want to use an external server or a back-end script to handle your result calculations, FlowStates make that easy to set up. We can simply utilize another add pause element just like we did for the keyboard input. However, this time, we'll use it to wait for the server response before moving the flow forward. I'm using the same approach here, a Boolean flag that keeps the flow paused. But instead of waiting for a keyboard input to flip that flag, I'll write a getResult method to fetch the data from the server. We no longer need the client to generate a random result. I'll strip that logic out of FlipCoin method, and a coin result will now be set in the getResult call. Now, when I press space, the flow moves to the getResult element. This triggers the call to our external server to fetch the coin flip result. In the event of network lag or a server timeout, the Flow controller allows you to monitor exactly where the sequence is hanging, making it much simpler to debug and handle those edge cases. That's it for this tutorial. Thanks for watching and happy coding. Enjoy creating with Incisor.